Hi, it's Jerry, and we're back with some more C Sharp training. Now we're going to try to actually start a little bit of programming. Now, in the previous video, I showed you how to actually go around Visual Studio. One thing I didn't show you is how to remove projects, but we're actually going to do that now. And well, it's actually a simple thing, and you probably got to know that if you played around with this. So you can just right click a project and click remove. So we'll remove both of those projects so that we actually have just the solution, and that what I actually wanted to have. Well, I don't care. Yeah, it asked me if I want to save changes to one of my projects, but I was deleting it, so I didn't care. Yeah, so we are now with an empty solution without any projects within it. And well, we're going to start actually programming, so I'll just add a new project and I'll call it the basics. Basics. Come on. And of course, it's going to be a console application. So, yeah. And now we'll look into what actually Visual Studio created for us, because we said, okay, a project can have some properties and they are stored in the well, within some files there. I'm not going to talk about them. And we can add references to our project. Right. There is some app config file. I'm not going to click it. Oh, okay, I can click it. It will show in Visual Studio 2013. In previous Visual Studios, it won't show. So you get previews of those files. But one most important file that Visual Studio created for us is the program CS file. And all files that have the extension CS will be the files that will contain our code. So yeah, now we're going to have a closer look at that file. And let me just maybe okay, I'll keep the solution here because the code is not too long yet. Okay, so first of all, what we can notice here is that we have a whole bunch of using statements, right? And we have a block of some code. So first of all, I'm going to actually talk about these usings. So we said that we can add references to 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 some tools that we can use um, in our programs, in our applications, and accept adding them, or besides adding them to the references, besides adding a DLL and then telling Visual Studio to copy that DLL. For us, we also, wherever we want to actually use it in code, we need to say that, okay, I want to use this particular tool. Now, we're not going to go into much detail yet on these. But just imagine that whenever you want to use a tool, you actually have to tell the computer, the program, that you're using a particular tool, or you're using a particular toolbox, and then you want to take a particular toolbox out of that box. Yeah, so these are the using statements. Now, second thing is we have this namespace that is called the basics. And if you remember about me talking about the project, if we go to the project properties, then we had this default namespace. And whenever we create a file, then we get that default namespace for our file. So we get the basics here, right? Because that's the default namespace for this project. Now, to actually describe what is a namespace, well, it's a really hard question. And I asked my fellow colleagues, and they were a bit like, yeah, I know what's a namespace. I know how to use it and stuff. But I imagined this something like this. Okay, first of all, it's a big bag, so you can put stuff inside. And second of all, it allows you to reuse names. For example, if I want to call something wrench, right? So I can't create two tools, two things that are called wrench unless they are in different namespaces. So in different collections, in different bags, right? So the this allows me to reuse some names, right? And be able to actually have like well, to be able to actually use the same names for different stuff. Second of all, and I think this is more important than actually being able to reuse names, because actually this is sometimes confusing when you use the same name for different stuff, and if you use it a couple of times, that's going to be confusing. But second of all, namespaces organize your tools. So imagine that a namespace is a toolbox, so that the name of the namespace should tell you what kind of tools you will get inside, right? And then if you open the toolbox, it might happen that you have some tools there and a few other toolboxes inside. So namespaces can actually go inside each other. So I could say like namespace my code, wherever that means, and open it up here and then close it right here, right? So now we would have this toolbox, the basics, and then when I open it and see what's inside, I can see another toolbox called my code, and maybe I can see another toolbox, my other code, right? Well, it's empty, but might be, right? So this is a way of organizing the code, right? And you don't have to put all the tools in one file. Namespaces actually, like the compiler Visual Studio, when it compiles, it builds your program, it takes all the files and sees like, okay, this is this namespace, this is that namespace, this is inside this one, and so on and so on and so on. If everything is correct, and if you didn't make a mistake, then it will put all the tools in the correct boxes, more or less. So I hope this more or less tells you what is a namespace. If not, then I'll try to figure out a better way to describe a namespace, but I hope this is enough. So we have the namespace, and now we have something called a class. And in the previous video, do you remember I told you that C# is a object-oriented programming language? Now, well, yeah, maybe let's have a quick definition of what's an object-oriented programming language. And, well, you can go to Wikipedia or any other Google's search site and then find some kind of definition. I'll try to create one out of my head. And I would say an object-oriented language, a programming language, is a language where you interact with objects, where the main idea of what you do and how you program is by creating relationships between objects and interactions between objects. So yeah. And in C#, some might say it's not true, but actually everything is an object. and I'll just make that statement. And yes, maybe it's not true. I'm not that great, and maybe I said something wrong, but I don't care. Everything is an object, and everything actually has to be an object. And a quick definition of an object uh, could be a class, right? So a class now, and we'll just have a quick definition of a class, and we'll be working with classes a bit later on, but just to have this quick definition for now, a class is more or less a blueprint of what is an object and how you can create this object, right? And our program needs to have at least one class, one definition of an object that will hold this main function. Now, why? Why? Well, because we need to have a starting point. We need to be able to tell where our program starts, right? So just for now, just so that we keep it simple, the main function is the place where our program starts and all the magic happens, right? So we will put our program in the main function. Now, there are a lot of languages there, and some of them use different ways of defining a block of code. In C#, we define a block of code with those, these are called, I think, curly brackets. All these brackets, they're I think they're called curly brackets. So let's just zoom in a bit. See, it's these brackets. Hope it's visible. So yeah, and let me put magnifier somewhere else. Okay, so we define a block of code by the curly brackets, and of course, well, each curly brackets might be encapsulated within others. So this is another block of code, and there is another block of code. Okay, so next up, we're actually going to learn about some data types, because, well, whenever you start programming, the first thing that comes in mind, at least for me, is like, okay, my program will actually be having some information inside. So for example, you might have some user interaction. The user types in something. Okay, but when he types in, then maybe you want to store it somewhere, right? Maybe you want to do some calculations. Then you have some numbers. Then you have to store them somewhere. Maybe you want to create a picture library, so you have to store those pictures somewhere, right? So you need to have some information types. Or holders, that's something to hold your information in, right? And for C#, it is really important to actually get to know what is the type of the information in the container that you have. It is really important. Of course, there are ways to actually say, like, okay, the type of that information will be defined whenever the program runs. So the type of that information will be defined on runtime. That's what we say. But usually what we want to do is just have that information declared, and we predefine that, okay, this thing will actually be storing numbers or text or pictures, right? Or music, for example, right? Okay, so C# has several basic data types, and I've prepared those data types on, well, well, maybe I didn't prepare them. I have this website, and I think it's very good. It's MSDN. So here we have the C# reference, and really, believe me, this is very good. And you can actually get to know a lot of information about C# just by going through this reference and reading through. So here are the most basic data types. And as you can see, we have boolean, byte, sbyte, char, and so on, so on, so on, so on. Now, I'll probably put that link somewhere here, and then you'll get that. Yeah, I think I'll leave the source code somewhere. I'll put somewhere. And then you'll find this source code in the description. Yeah, we'll try to use some of these because when you program, you don't use all of them. Usually, you use a couple of them, but from time to time, it's useful to know what data types you actually can use. And this reference is quite good. So if you run into some problems and want to have a different data type because you need to, then you can come back to this reference and figure that out. Okay, I like to make the group these data types into a few sections. I'll talk about comments in a second, don't worry, but you can actually comment code in C# so that you can add free text there. So I like to group data types into like numerical data, right? Text data, and some logical data, I would call it. Cool. Okay. So these are like the three groups that I put information in. Of course, you could say like, okay, where do I put pictures in? Yeah. Well, you don't. This is like the basic data types, right? And pictures would be, I don't know, media or something like that. But I would have to create another group. But I want to start with the basic data types, and then numerical data. You can have like whole numbers, right? And then you can have floating point numbers, huh? Right, so like real numbers, right? Text data. I usually say we have like longer text, so multiple characters. And text data is also a single character. Right. And what I mean about logical data is like true or false. And that's it, right? So that's how I divide like the information, the simplest information that I have in my programming, in my programs. I just if I think about data types, and the basic data types, I think about like, okay, we have just numbers, and we have just some text information, right? And then we have the logical data, right? And now looking at that list, so let's just move it back here somewhere. Maybe I can, I can't. Come on. Yeah. So we have this first one. It's bull, right? Okay. Yeah. Okay. Before we do that, yeah. Okay. We want to put information in some kind of container, right? So a container in C# is actually a variable, right? Can hold information. Okay. And whenever we want to use a variable, we need to define its type and then define its name. That's the least we need to do to get a container to be able to hold some information within. So to be able to use, we need the type and a name. Right? Yeah. And that's the least, right? So for numerical data, okay, let's start with the logical data because that's what the reference started. So I'll put that here. Okay. So the first that went on that list was the Boolean data type, right? And that's actually the Boolean data type. If we click the reference and see what they actually wrote for us, it's like the bool keyword is an alias. It is used to declare variables to store Boolean values true and false, right? They call it Boolean. I'm not sure if this is something that everybody can understand, Boolean. So that's why I call it just logical data, right? So as I said, we want to have a container to hold our logical data. So first of all, we need to say what type that this container will have, this variable will have. So I'll say bool. And you can see whenever I start typing code, you will see this pop up below. And this is normal behavior of Visual Studio. It always does that. It will try to actually figure out what are you trying to write, if you're writing code, of course. And then it'll try to help you. So when I started typing BO, right, or B, and it will remember last usage, and then it will try to actually give you the best choice that you might want to use. So it will try to figure out what you want to use. And then if you want to use it, so you can use arrows, for example, right? You can use arrows. If you want to use it, then you can hit either enter or tab. So if you hit tab, and you get the whole word. And then if you go hit enter, and you get the whole word as well. Okay, so as I said in the line above, we need the type of the information, and then we need to have a name for that variable. So logical data, we call it. The name needs to be without any spaces in between. So we can't say logical data. The Visual Studio will ignore everything after that space. So it will figure out like, okay, this might be the name, but I don't understand what this is, right? So it will not like this. Okay, but now when you have the name, and whenever you like finish up a instruction, so okay, here I am instructing the program, the computer, that I want to create a certain variable that is Boolean, right? And its name will be logical data. In some programming language, you could leave that as is, but in C#, whenever you finish an instruction, so that's one piece piece of instruction, and you have to put a, is it called a semicolon? I think so. Yeah, then you have to put a semicolon. And the same as in Microsoft Word, Visual Studio also highlights errors. So you had this red lines, which means that's an error. But you also have these green lines, which are not really errors, but it's like Visual Studio is trying to tell you, okay, this is not an error, but maybe you're doing something stupid here. And if we go over that, then Visual Studio will tell you like, okay, this variable that is named logical data is declared, but it's never used. Okay, it will be okay for us now because we're just going to be declaring variables. And what we're doing here, so saying the type of the information that we want to store somewhere in the computer, right? And the name of that information so that we can somehow access is called declaring, right? Because what the computer will do for us is it will actually go into memory and find a free space that will be able to hold this much information, as we said, the type of the information requires, and it will give us the address of that information. But if we had just the address of that information, it would be really hard to actually go programming because those addresses are just numbers and they are meaningless. I mean, they don't have any meaning for humans. So for us to be able to actually do programming a bit faster, this programming language allows us to actually have names, right? Okay, yeah. So we have declared a Boolean variable, and Visual Studio is just saying like, okay, you don't use it, so maybe you don't need it. Yeah. And later on, it is useful because sometimes you have a whole bunch of variables declared in your code, and maybe you want to clean it up so that it looks nicer and it's more readable. Because a whole bunch of variables that you never use, someone will actually read them as like, I'm trying to memorize them or something, and then he used only 3 of them. How stupid, right? So Visual Studio will tell you you're not using these, so maybe you should remove them. Okay, so this is logical data. Now I said we have numerical data, and we can store like whole numbers. And if we go to the reference for whole numbers, you can use you can use byte, you can use sbyte, you can use decimal, you can use double, you can use float, you can use int, you can use uint, you can use long, you can use ulong, you can use short, and you can use ushort for numbers. But let me just write those few ones that I think are the most useful and used most often, right? So let's declare a few variables. First one is int. It holds whole numbers, right? Second one is float. And it holds floating point numbers. So and you might also notice that I'm typing each word with a capital letter, and then the first one is a small letter. This is something you don't have to do that. Of course, you could write this with like underscores. You won't be able to see the underscore. Let's just assign value to it. I'm not using it. Can I ignore this? Nope. Too bad. Okay, there is an underscore. You could use underscores. You can make the names as you please. This is just something like common practice. So yeah, way I do this, but you can make your names as you wish, as long as they are meaningful. I really really strongly recommend to use names that are meaningful because it makes your life easy. Well, easier. Yeah. Okay, so we have the whole number of type int, and then we have another number that is a floating point number of type float, and then one other which is called double, right? And point number with higher precision. So both of these types hold a floating point number. A float has a smaller precision than a double. But what is the advantage of a float? Well, nowadays maybe it's not that really important. But well, 8 years ago, 10 years ago, it was a big deal if you used too much memory. In general, double takes double memory. So like if you're holding a number and you want it to be a floating point number, and you are really you need to be savvy on memory, then you should be using floats. And at some in some circumstances, like the values that are returned from either you get a tool from a library or something, the values that are returned might be floats, and then you should see that, okay, what you're getting is a float, and then if you want to send it back, then maybe you have to actually send a float and not a double, right? So yeah, there's one more that I want to just declare and say a few words about it, but maybe this would be best if this was your homework, just to read it on MSDN. And this is called the decimal type. And the decimal type is also a floating point value, and this actually has most precision from the three, right? And if you really need precision, then the decimal type will give you the most precision. And a lot of libraries that are actually doing calculations will actually require and return decimals. So you get decimals from them as results of some calculations, and then usually they will require decimals or not, depending on what the calculations are, right? So floating point number with even higher precision. Okay, so we have 4 data types for numbers, and now we'll jump into some text data. And there are actually, yeah, I think there's no more than 2 data types that should be mentioned here. So one is just char, which can hold a single character. And then there is the string, longer text. Let's call this longer text. like this. Okay, so yeah, these are the basic data types, and I'll just wrap up here, and we'll continue with using those variables, those data types in some operations, and I'll also show you how to group the code in the second video. I just need to have a break, so thank you for watching, and see you in the next video in a couple of seconds. Bye.